Okay, everyone. Turns out at kind of the big climax of this section, I'm going to do in a rather short, to the point video. So the theory is in the textbook. Feel free to read that all, but I'm going to do an example that just shows you the end result. And the theory is very similar to the kinds of things we've already done for second order differential equations and so on. So instead of going through that all again, I'm just going to show you how it all works. So suppose we want to find the general solution to this system of equations. X prime is equal to x plus 3y, y prime is equal to 4x plus 2y. And just to stress the point, we can write it differently. We can write it like this instead in matrix form: x prime, y prime, 1, 3, 4, 2 times xy. It gives you the same thing. Or if you want to, you can call this thing the derivative of the vector x, and then xy is the vector x. Okay? So if you wanted to, you could even say this thing is equal to a times this, where of course a is just equal to 1, 3, 4, 2. So any of those are various ways you'll see it in the literature, including in my textbook. So what's the solution? Well, it turns out that I chose this one because we already learned in example 719 from a previous section that the matrix 1, 3, 4, 2 has two eigen values. It has an eigenvalue of -2, and when we found the associated eigenvector, the associated eigenvector was -1, 1. And let's see. I can see. I'm going to turn off this light. See how that works. No, that's no good. So there's just going to be a little bit of glare there. And then eigenvector of 5 has, eigenvalue of 5 has the associated eigenvector of 3, 4. Okay, so that was all what we've done already. So it turns out that's basically all the work that's needed for this. So we can just peel this off to get the solution. So the general solution is this right here. It's just going to be alpha times, let's do this one first, -1, 1 times e to the -2t plus beta times the eigenvector 3, 4 times e to the -5t. So you can write it like that, or if you preferred, you could write it as x of t is equal to -alpha e to the 2t plus 3 beta e to the -5t, and then you could write, of course, y of t is equal to what? Alpha e to the -2t plus 4 beta e to the -5t. So you could write it either way. Okay? Either way is fine. And so that's the general solution. So then what if you want a specific solution which satisfies that? So that if you at the time equal to 0, the value of the function is -310. Well, then all you do is you stick in 0, and you're going to get what? X of 0 is going to be equal to -alpha plus 3 beta. And that's got to be equal to -3. And y of 0 is equal to what? Alpha plus 4 beta. And that's equal to 10. So that's just a system of two equations, two unknowns. If you add them together, those are going to add out. You're going to get 7 beta is equal to 7. So beta is equal to 1. As soon as you have beta is equal to, beta is equal to 1, then alpha would be equal to 6. So it would just turn this into a, what did I say? Alpha is 6, and beta is 1. So there would be the specific solution that satisfies that. So there you go. That's all there is to it. So those of you that are taking the course, if you've done the problems from chapter 7, then you can just use those to do the problems from 8.4, similar to what I just did here. So there you go. Very good. So now in the next lesson, by the way, we're going to see what do these things graph into? What are the solution curves of these kinds of things? And it turns out there's some really interesting ones. Okay, so we looked at one already, an ellipse, but we're going to see a lot more interesting ones as well. Very good.